So then I will continue with the agenda of today. We have 3 presentations in total. We'll start with the presentation from the students of ITS, followed by Universitas Negeri Malang and then Universitas Brawijaya. Each will have 15 minutes to present their presentation. And after that, we will open the floor for any questions or feedback for the students. And lastly, we will also end the session with the announcement of the winners of the social media challenge. So before we start, are there any questions from anyone? If not, then I would like to give the floor to the students of ITS. Good luck. Oh, yes, I see a slide coming up. The floor is yours.
Good morning, everyone. Welcome to today's presentation on the Welang River Transformation Project conducted by ITS Surabaya. In this presentation, we will delve into the Welang River Transformation Project, which endeavors to tackle the pressing issues facing the Welang River and its surroundings areas. Our primary objective is to implement effective solutions for flood mitigation and water pollution control. My name is Mashita Dewi, and I'm joined by my colleagues Jasmine Rizkimukti, Deviana Setiadipura, and Nabilla Nurul Iqlimah under the supervision of Pak Muhammad Bagus Ansori and guidance from Pak Umbaro Lasminto. Before we proceed, let's take a look at some of the documentation we gathered during our survey process. On this slide, you'll see visual representation showcasing the current state of the Welang River and its catchment areas. And as we analyzed the situation, we identified two major problems plaguing the Welang River area. Firstly, there are recurrent floods affecting several areas, including Subdistrict Tambarjo, Subdistrict Karangketuk, and Subdistrict Sukorejo. Additionally, water pollution is rampant due to the discharge of household, plant, and industrial waste.
Okay, so moving on to the next slide. So the study location in this research will be in Pasuruan Regency, specifically in Walang Lama or Sukoharjo and Sumber Pinang, Sidogiri. And the Wolang watershed itself, the analysis was conducted using ArcGIS software, and the result shows that Wolang watershed is delineated with an area of 491.699 kilometers square. Then the first step is identifying which rainfall stations influence the study area. The Thyssen polygon method is employed using ArcGIS software, resulting in outcomes as shown in the slide, where the following are the 10 rain stations that influence the Wolang watershed, along with the area and coefficient of each influential rain stations. Next is the calculation of the average daily maximum rainfall is conducted from the year 2014 to 2023, and the summarized result of the calculation itself over 10 years are presented in the following slide. Next is doing the frequency statistical parameter, where the frequency analysis is performed to calculate basic statistical parameters, which later on will determine the appropriate statistical distribution. Here is the summary of the basic statistical parameters calculation. Okay. Next is the determination of plane rainfall is carried out using a parameter test and also a goodness of fit test. And here is the goodness of fit test using chi-squared method and Smirnov-Kolmogorov test, where the result is it shows that log Pearson type 3 distribution method meets the requirement, and therefore using log Pearson type 3 distribution method, the design rainfall is then calculated for the return period of 2, 10, 25, 50, and 100 years. And here we compare our calculation result with PUSDA and TRMM, and it can be seen in this slide that our calculation result is already similar to PUSDA's results.
Okay, determination of the runoff coefficient value in the Welang watershed is based on land use data for past variancy in 2021. And obtained runoff coefficient value is 0.52. The distribution used to calculate our rain is the Mononobe distribution. The calculation is based on the longest concentrated rain in East Java, namely 5 hours. The recapitulation of rainfall distribution calculation is shown in the table. There are several parameters for calculating the design flood discharge using the SGS hydrograph. The first is curve number. The curve number value in each subbasin is determined by land use and soil type. The slide shows the land use of Welang watershed. From combining land use and hydrologic soil group, curve number is obtained as shown in the table. The next parameter are percent impervious and initial abstraction. These two parameters are related to soil capacity. The previous parameters are used to calculate time of concentration and lag time for each subbasin and ridge as shown in the slide. After running the model on Hec-HMS, the simulation results were obtained. The left image shows a schematic of the hydrological model in Hec-HMS, and the image on the right shows the result of flood discharge using the SES hydrograph. The maximum flood discharge of the Welang River is in the range of 237.9 meter cubic per second in the 2-year return period to 588.7 meter cubic per second in the 100-year return period.
The analysis continued with 2D modeling on HEC-RAS, which the parameters used for RAS mapper are the terrain data, which needs to be modified for the Welang River and the floodway, and land cover data to obtain the Manning coefficient. And on geometric data tools, the 2D flow area used is with the mesh with unit 25 times 25, and the break lines is used on the open water areas, and the boundary conditions line used for the upstream is on the junction of Sumber Pinang and Welang River, and while for the downstream is on the Welang River outside the flow area. And the flow area needs to be connected to the modified terrain and land cover. And on unsteady flow data, the flow is using the result from Hec-HMS on the flow hydrograph for the upstream for every return period. And for the downstream, the boundary condition type used is normal depth. And for the unsteady flow analysis, the programs to run is geometric preprocessor and the unsteady flow simulation. And the computation setting is set into 20 seconds for the computation interval and 1 hour for the other interval. Okay. The model is validated using a qualitative method by comparing the last great flood, which occurred in around 2007 until 2008, and the modeling result for 10 years return period. And based on the residence, the water height reached 2 meters, which is also shown in the picture. And it matched the water depth from HEC-RAS result, which is 1.95 meters. Okay. The simulation result is shown in the floodplain pictures, where there are several colors to differentiate the area for each return period. The higher the return period, the larger the inundation area. From 2 years to 5 years and 5 years to 10 years return period, the inundation area expands significantly, but from 10 years to 25 years and so on, there is not much difference from the inundation area. And the rainfall for 2 years return period resulting in a flood on the crops area only, while since 5 years return period, the residential area is also flooding. And on existing conditions, there is 3 meters high of flood retaining wall on the downstream of Welang River. And based on 1D simulation for Welang River, the flood wall managed to prevent overflowing. So the flood wall is indeed works for now, but it is not a sustainable solution for flooding. Okay, so here is the alternative solution ideas, which are retarding basin, which can hold water, which can decrease the flow discharge of the river. And retarding basin can use a grassy area, which is very sustainable, and rainwater harvesting, which can reduce pressure on stormwater drainage systems during heavy rainfall. And the concept of green water infrastructure can also be applied to manage stormwater and reduce runoff, and channel dredging to remove clogging barriers and creating interconnected channel networks. So here is the site plan for the proposed retarding basin. Both needs to be located on the upstream of Welang River to reduce the runoff. The first one is located in Semut Village, which can hold up to 196,548 cubic meters, and the other basin is located in Linggo Village that can store up to 1,202 cubic meters. Okay, and rainwater harvesting could be done on individual home and community based. The individual home rainwater harvesting enables existing buildings to utilize previously unexploited roof areas to save water, and its ability to collect rainwater can reduce runoff and prevent flooding and more sustainable water supply for the building on daily basis, but it costs more. Meanwhile, the community-based rainwater harvesting the storage is simpler and can be in the form of a pond, barrel, or other similar storage designated as a rainwater reservoir. And this model does not have a system for filtering or a system for absorbing water into the soil, and generally used rainwater from storage containers for irrigation or watering plants. Okay, and green infrastructure can be combined of permeable pavement, rain gardens, and green roof. Permeable pavement enables water to seep through and infiltrate the soil, and it is low of carbon emissions. And for the rain garden, it can collect water from surrounding area to reduce runoff and become a small basin to hold the water temporarily. And for green roof, it has many advantages, which are reducing air pollution, reducing the energy consumption, and reducing noise. It also enhanced the quality and water management, and also increased the roof's durability. But the installation must be done by experts and cost more than usual roof. Okay. And channel dredging can affecting the surrounding biodiversity, but it is indeed it is needed to remove the sediment on the channel bed and restore it to its own capacity. The sediment will eventually accumulate slowly, so dredging needs to be done periodically. Meanwhile, on the Sumber Pinang, the problems it has the problems with its drainage network, which results in flooding around the Sidogiri Islamic Boarding School. For the 5 years return period, it already full on capacity, while it's on full bank capacity on 10 years return period discharge. That's all from our presentation. Thank you for your attention.
Yes, thank you very much for the interesting presentation, Mashita Dewi, Jasmine, Deviana, and Nabilla.